In the previous video of this observability series, we understood what exactly is observability, how it is different from monitoring, and all other components of observability. We'll be using some of those concepts in this video, so make sure you have watched that video before this one. And if you are new here, hello, my name is 𝗵𝗺 and you are watching Tech Tutorials with 𝗵𝗺, and I talk about DevOps and cloud all day long, and not just talk about, we do end-to-end demo in this particular channel. But this video is again a theoretical video because we are still understanding the concepts. There are a lot of concepts when it comes to observability, so we are still going through it, and in a couple of videos we'll be getting our hands dirty with the real-time project, so stay tuned for that. Let me just start with this video. Okay, so we need to understand three pillars of observability. First is log, second is metrics, and third is traces. We need to understand all three and where do we use each of these. Okay, so this helps you improve your debugging. This helps you slow down the debugging time and helps you find the root cause of the issue faster. So when you face an issue, you have no idea what broke, when it broke, or how many users are affected. You SSH into the server, you scroll through logs, raw text files, you scroll through multiple log files, and then after few minutes, you still don't know what exactly is wrong with your server because you don't know the exact place where to look for issues. Right, you have logs, you have everything, still you have to pinpoint that exact place where your issue is occurring. Let's try to understand these three concepts with the hospital analogy. Okay, so first is logs. Consider logs as the notes of your nurse. When you arrive at the hospital, the nurse enter or the receptionist enter notes in their diary or in their computer. You know, patient arrived at 3 p.m, complained of chest pain, given aspirin and something like that. So it is the detailed written account of specific event. That's your log is. The metrics are the vital signs. Your heart rate at a particular time, your blood pressure measured and plotted every 15 minutes and so on. You know, so metrics are number tracked over particular time. In case of a server, it's CPU utilization over 15 minutes or memory utilization after every 5 minutes and so on. Then we have traces. Traces is the sequential path through multiple systems. In the hospital analogy, when you go to the reception to triage, how much time it took, from triage to radiology, how much time it took, from radiology to ICU, how much time it took, with timestamp and with the one-liner record of that. So that's your journey map, and that's what we call traces in terms of computer systems. So let's have a look more detail in the first one, which is the logs. So the log is a record of a discrete event inside your system. Okay, log has a particular format which will have the timestamp, the severity level, and the context. Okay, timestamp will be there in a particular format, your date with hour, minute, second, and sometimes milliseconds as well. Then severity level, error, warning, info, and so on. Then you have your context. Okay, what happened? If it's an error message, so something like payment failed for this order. If it's just an info message, so let's say payment initialized or payment started, something like that. So this entire entry, which will have a timestamp, a severity, and the context, considered as a log entry. Okay, when do we use log? When you need to answer what exactly happened with this specific thing. Okay, so let's say something failed, a payment failed. So you want to know what exactly went wrong with that. So you check that log entry and you find out, okay, so payment failed for this order because the card was declined at this particular timestamp. Okay, so that's what log provides you. Then there are two types of logs. There is structured log and then there is unstructured log. Unstructured log is something on the left side which says a text message, right? Payment failed for user John, order 5521, card decline. Okay, it is good for human readability, but it is unsearchable by machine because it does not have a predefined format, and it is not easy to parse by machine, by API calls, or by different monitoring and alerting tools. And on the right side, we have a structured format, which is, let's say, in a JSON format, which will have a key value pair. Okay, something happened at timestamp this, level was this, order ID was this, user email service, and so on. So when your system has to find out, it will go to that particular log entry and look for order ID or service or something like that. It knows where to go and where to find. It is faster, it is reliable, and it will give you the exact same result every time because it's written for machine and you can filter it at scale. Okay, let's say you have to find out all the error messages or all the order ID of the error log. You can easily filter that applying some conditions. When you have, let's say, 50 service writing million lines a day, structured log are the difference between finding a problem in 2 minutes versus 2 hours. If you have thousands and 10,000s of users producing, like, say, millions of log entries a day, you have to go and find for each and every entry to get something meaningful out of it, right? But with the JSON file or with the structured log entry on the right, it will be easy to filter at scale. So that's the main difference between these two. Now, the second pillar, which was metrics, which we looked at the vital sign analogy. So what that is, it's a number that is measured repeatedly over time. Okay, it's stored in a time series database that represents how your system is performing. Okay, so let's say your users were complaining a slow response time, right? So you go and check at what time it started happening exactly, and then you will know what happened at that time. So for example, you say your request rate per second was spiked from 500 to 2000 something, right? And there is a sudden spike over there. So you instantly know something happened at this particular timestamp. So you know which timestamp to check for further. Now you don't need to look for thousands of log entry. You just look at your data in the real time to understand the problem. So there is a term called minimum viable observability, and it has the 4 golden signals. These 4 golden signals are important. Okay, first is latency, which means how long does it take to respond, and it directly dictates the user experience. And we have already looked into P99, P95 and P50 latency in the previous video. I'm sure you are aware of it. Then we have traffic. That means how many requests per second you're getting. It tells you the current load on your system. Then we have error. What percentage of requests are falling? 1% of 10,000 requests per minute, which is 100 failures per minute, for example. Then we have saturation. That means how full is your system. The only predictive signal, for example, 95% CPU, disk utilization, disk is full, like 89% memory, something like that. Okay, so you need to understand these 4 golden signal, and this is minimum for a observability to be implemented. Okay, you should have these 4 signals. Now, it is important to understand why we need to track the latency in percentile instead of average. Okay, so let's say your users are complaining about the slow response time. Okay, so you took the average response time, which is 332 microseconds for let's say 10,000 users. So it won't show you anything. It won't show you the real picture because not every user is impacted, right? But the average is for all the users. So that is where you need to use the percentile. Now with percentile, we have 3 different percentiles: P50, P95 and P99. P50 meaning you are only taking the average of 50% of the users. Okay, so it will show you, let's say, 103 microseconds, which is a typical user experience. Then we have P95. Okay, P95 meaning the 5% unlucky users, or the 5% of the users that are facing the issue. We need to take the average of only those 5%. And then we have P99. P99 is your 1%, top 1% impacted users that are facing this issue. Okay, so this will tell you the truth about your worst impacted users, okay, or the most unluckiest users. So P99 gives you the better picture. So let's say your 1% users who were getting the latency hit. Now out of those 1% user, what is the average latency time for those users? So that comes to 2400 microseconds. Now with average it was coming as 332, and with P50 it was coming as 103. But this shows the real picture. So true SLOs, SLO is service level objective, and we'll have a separate video understanding SLO, SLIs and SLAs. But for now, just understand SLO is a service level objective. That means what you have promised to your users and what you are giving to them. Let's say if we have promised that you will get 100 ms response time or 100 ms latency at P99. So that's a type of SLO that you are promising your users. That is the promise of a service that I'm delivering to my users. That is an SLO. So SLOs are defined on P99 or P95 or P50, not based on the average. So it is important to understand the percentile average concept in this. Now there is a term called cardinality trap. We have already looked into cardinality. So the low cardinality is something like HTTP status. We are only tracking, right, the status code or the environment or the region. Does not provide you the extensive data about the issue when it comes to debugging. But if you have high cardinality implemented with user ID, request, order ID, and each and every field of every request, that provides you better observability. But it's in a danger zone if you are using high cardinality with millions of unique value and you are passing it into metrics. So the rule of thumb is never put your high cardinality data in metrics. It slows down your monitoring and spikes storage cost. So you need to put them in logs and traces. Okay. Low cardinality is still fine to put them in metrics because you are just monitoring, let's say, how many requests are getting failed or how many requests are getting success, how many 404 errors are you getting. That's still okay to put that in metrics and dashboards. But because this high cardinality, meaning 1,000 times more than the lower cardinality data, it will increase your storage cost, it will slow down your system, and it will not be that helpful. So the rule of thumb is put the high cardinality data in logs and traces. So the pillar 3 is traces. What exactly is a trace? A trace is a complete end-to-end record of a single request across every distributed service it touched. The request flows from front end to API gateway to payment service to database query. Now the trace shows the end-to-end record of a single request. When you submitted a request from the front end, it generated a unique trace ID. And that trace ID is the unique tracking number for the whole journey. When your request goes from one stage to another and it comes back, everything is tracked under a single trace ID, which is a unique trace ID assigned to your request, each of your requests. Okay, so it is important to monitor and capture the traces. So now let's say you were getting the latency, right? You were getting latency in the request that you have submitted. Trace help you identify at which particular service it spiked the latency. Now with this visual, we get to know that, okay, the request was slow because there is this database query that was taking 795 milliseconds. So you instantly know something is wrong with the database query or something is wrong with the database. You don't have to go and try each of the services. You just directly go to database and look into that. It will help reduce your debugging time to 100x. Now why traces matters? Because it helps you reduce your MTTR. MTTR meaning mean time to repair. Okay. So the mitigation time, it helps you reduce that mitigation time and to find the problem. So without traces, if we look at this particular image, without traces, there is a detection which has been done by our system. Then most of the time you spend is on diagnosis, logging into the server, guessing where the issue could be. So you are juggling here and there, you are logging into multiple services, reading logs and other traces that you have, and then you finally fix the issue, whatever you find. So this increases your mean time to repair, it increases your diagnosis and repair time. But if you have traces enabled, now you know where the issue is. You go and you use some diagnosis tools such as Jagger, and then you see the slow database span, and then you go and fix the issue. It does not make coding the fix faster because it will still depend on the other things, but it will help compress the diagnose time from 40 minutes down to 3 minutes, for example, right? It will help reduce that time. So this is why traces are important. Now, we have discussed multiple signals. Now, which signals are for which? So what exactly happened with order 5521? You can find that in the log. How many order failed in the last 10 minutes? You can find that in metrics. Which downstream server caused my downtime? This will be in traces. Is CPU creeping up the last week? You can find that in metrics by looking at the historical trend of that particular metrics, which is CPU in this case. What was the exact syntax error before the crash? Again, you can check that in log. It is important to understand which signal answer which of the questions, so that you know if you have understand the difference between each of these signals or not. Okay, so the unified workflow goes something like this. So you have alerts. Alert is something like a spike in P99 latency that triggered the pager, and we know something is broken. Then you open the trace ID to find the bottleneck, for example, a slow database query, and now we know exactly where it is broken. And then using logs, you diagnose, you read the structured JSON attached to that specific span to see the exact syntax error. We know exactly why it is broken. So this unified workflow of observability help you answer what is broken, where it is broken, and why it is broken. What, where, and why. It helps you answer all those questions, and that's end to end for it. All right, yeah, so that's it from this video. I hope you found it helpful. I hope you learned something new. If you did, let me know in the comment and share it with your friends, colleagues, and whoever is learning observability these days. It might help them. In the next video, we'll be looking into OpenTelemetry, which is an open source project, but it is important when it comes to observability. Okay, so we'll look into that, we'll understand that, we'll try to host that. Thank you so much and happy learning.